Assalamu alaikum. Today we will be solving a problem of a string being subsequence of another. So we are given two strings S and T. We need to return true if S is a subsequence of T and false otherwise. By definition, subsequence of a string is a new string that is formed from the original string by deleting some of the characters without disturbing the relative positions of the remaining characters. For example, we have string A, C, E. This is a subsequence of string A, B, C, D, E. And this is because this string, we can say that this is a string S, respect the order of insertion in this string. So S is a subsequence of T, and we can return true in this case. So the approach we're gonna be using is a two-pointer approach. We need to initialize our two pointers ing to 0. Then after that, we're gonna iterate through both strings using a while loop. Inside of our loop, we will check if the character at index I in string S is equal to the character at index G in string T. If they are equal, we can then increment the pointers ing in each iteration. Finally, if I reach the end of string S, this means that all characters of S have been found in the correct order within T, and the function return true. Otherwise, it return false. Let's see this in a real example. So here we have two strings S and T. We're gonna position our pointers I as index 0 in string S and G as index 0 in string T, and you can see that both start with 0 because we always start with index 0. This has 3 characters and this has 6 characters. Now we can check. So the character here is A. We can check if this equal to this. So we can see that A is equal to A. This is valid. Now we can increment our pointers respectively. Okay, now our pointer here is in the second position, which is letter B. Now we're gonna check, is B equal to H? No. Now we're gonna increment this second pointer to the third character. Is now B equal to B? Yes, this is valid. Now we can increment our I index to the last index, which is C. So is C now equal to G in here? No. Now we need to increment the G index. Is G now the character at index G equal to the character at index C? C is N equal to D. We will increment again to the last character, and now we can see that yes, C is equal to C. This is valid, and our loop ends here. We have another example in here which is not valid. The output is false because this string has A, X, C. The other one doesn't include the letter X, so this is obvious. So our solution here, as I already explained, we will initialize our two pointers to 0, ing. Now we're gonna be using a while loop, and the choice of this loop is more appropriate. You may wonder why. This is because the loop continues until certain condition is met, which is the traversal of both strings. The number of iteration is not predetermined and depends on the length of string S and T. On the other hand, the for loop is best suited when the number of iteration is known in advance. So inside our loop, we're gonna check whether the character at index I in string S is equal to the character at index G in string T. If this condition is valid, then we're gonna increment index I and index G respectively. After that, we can check if I equal to the length of S and return true if all characters of S have been found in the correct order within T. Otherwise, we will return false. So you may wonder why you're not seeing true or false in the code, but this is because this return line, is a boolean. This is a boolean expression. If the condition is true, then this function return true. If the condition is false, then this function will return false. The actual values, true or false, are not explicitly written in the code because they are the implicit return values based on the boolean condition. Okay, now here is a result of my submission on the LeetCode platform. So it runs on 300 milliseconds and use 149 megabytes in memory. Now let's talk about time and space complexities. We can say that time complexity is linear because the algorithm iterates through the strings once, and the number of iteration is proportional to the length of the shorter string. So it's big O n. Now the space complexity is constant because the algorithm only uses a fixed amount of extra space to store the indices I and j regardless of the input size, and so it is big O1. So that's it for today. I hope that this makes sense and you understand my explication. I hope you enjoy my video. Thank you for watching. Bye bye.